Good morning again, my math friends. It is Mrs. Conlon. We are going to do Chapter 11, Lesson 4 today, which is mean absolute deviation. So here's advice for you. First, this is brand new stuff. You've definitely never seen this before. So go in this with an open mind. You might watch this video the first time and say you don't understand it, and that's okay. My advice always when we start something new, watch the video once just to watch it, and watch it with your eyes and your brain. Pay attention. After you watch it the one time and really had paid attention, watch it a second time, this time with paper, and pause and take notes and follow along. So that would be my advice for this. I'm also going to post other people's videos that go with this same concept, so you can see other people do it on YouTube. We are still in Chapter 11. Chapter 11 is statistics. So maybe you love crunching numbers, you love working with a calculator. You can use a calculator in this lesson. And statisticians analyze statistics. Probably the number one place you've seen that is in sports, but it's also in sales. And it's for people who really love math, crunching numbers, and analyzing statistics. So maybe this lesson is for you. So the first thing I would really like to do is even tell you what these words mean all together, because I'm looking at it and I'm not even really sure what all that means, right? Okay, so the first thing you need to know is what you already know. Mean means average. We already learned that the mean means the average, but obviously that's not all we're doing today, right? All right, so when we talk about absolute, do you remember that we did absolute value, right? Do you remember the absolute value bar? So the absolute value of 5 is 5. That means 5 is 5 spaces away from 0 on the number line. We also did absolute value with negatives. Negative 16 is 16 away from 0 on a number line. So that's what absolute means in mean absolute deviation. Okay, now the word deviation. So if I talk about the word deviation, it comes from the word deviant. Okay, so a deviant is how far away from accepted standards. Okay, so let's not talk about math for 1 second. In life, in books, in TV and movies, they might talk about a person being a deviant, right? And when I watch my son and his friends, let's talk about how kids dress, right? My son's in 7th grade right now. So when I look at all of his friends who come over, they're all wearing Under Armour, Nike, Reebok, Adidas, sweatshirts, shirts, the pants, the sneakers. They all kind of look the same. They have interchangeable wardrobes. Sometimes you'll run into the kid who doesn't wear all that and dresses very differently from the way the quote normal kids dress, right? So if it's accepted standards, another word for accepted standards might be normal. So when we're talking about a deviation, we're talking about how far away from normal something is. So now let's get this to math. We're going to find the average of data. We're going to find how far away from the average each number is, and then we're going to talk about how far it deviated from normal. So I'm going to keep coming back to this paper because I don't want to just crunch numbers. I want you to know what the crunching of the numbers means. So if you can't tell already, this is going to be a bit of a long video because there's a couple of steps that I want to show you. So you know what we'll do in the meantime? We'll open ourselves a nice can of, let's see, we got cranberry lime seltzer. I just got my son onto this one, and we'll have time to drink that in this long video. Okay, and you know what else we need to do real quick? Hold on right there. We will check in with, there's Miss Daisy. Miss Daisy's going to sleep through this lesson, no doubt. Doesn't she look like a little piggy? She looks like a little piggy. Okay, got myself my setup over here, and we are ready to go. All right, so do you remember the pink teaching pages? There we go. Right, obviously, thank gosh I have a printer at home. Right, so we're going to talk about the mean absolute deviation, and this was just to remind you we are in chapter 11, lesson 4 from the ebook. Okay, so I'm going to move this up, and here's our first example. Okay. So in case you didn't hear all those papers moving, I already did this work on separate paper, and I used a calculator. So even though I used a calculator, I'm still going to show you all the work that I want to say. Okay. This table shows the maximum speeds of 8 roller coasters. You know what I say, this information is true. I don't know what 8 roller coasters these are, but I know this is true information. Find the mean absolute deviation of the set of data. Describe what the mean absolute deviation represents. Okay, I want to know how far away from normal these numbers are. Okay? So let's see what that even means. The first thing I'm going to do is find just the mean. So let's write, maybe we'll write some steps, yes? I want to find the mean. We've already done that. That was lesson 1 in this chapter. So to find the mean, I'm going to add up all these numbers, okay? When I get the sum, I get 512. 1, 2, 3, 4, 5, 6, 7, 8 divided by 8. So I used a calculator for that, but I'm still showing this work. And when I find the mean and I do 512 divided by 8 on my calculator, I get that the mean is 64. Okay. Then I'm going to, if this is the mean, I want to know how far each number deviates from the mean. How far away is each number from the mean? Okay, so I see that if I do 64 minus 58, let's see, maybe I'll do that up here. Okay, I'm going to do the larger absolute value minus the smaller absolute value, right? 14 minus 8. Okay, so maybe if I put the number here, okay, 64 minus 58 is 6. Okay, now I'm going to take the larger absolute value minus, I'm always going back to the average. Okay, I'm trying to take some pauses so you could see what I'm doing. 72 is 8 away from 64. Okay, I take the larger absolute value minus the smaller absolute value, and I get 24. I take the larger absolute value minus the smaller absolute value. I did that one in my head. I take the larger absolute value minus the smaller absolute value. I know I could do that in my head also. Okay, now I have 80 minus 64. Let me put that like that so I don't get confused. 80 minus 64, I'm always going back to that 64, and I get 16. I can do this one in my head, larger absolute value minus the smaller absolute value. And then I have 64 minus 48. Okay, 14 minus 8, and I have another 16. Okay, so let's recap what those other numbers even mean. This is the average of the roller coaster speed, 64. So first I found the average, then I found how far away from the average each speed was. I found the deviance, right? So I am going to find, let's see, how could I phrase this? The absolute value of the differences, right? I subtracted between each value in the data set and the mean. So it has to be positive. You do the higher number minus the smaller number, so you find the absolute value, and these are all going to be positive numbers. Okay, was that a 24? Okay, now I'm going to take these numbers and I'm going to find the average of these numbers. I'm going to find the average of the deviance. So that means I'm going to add 6 plus 8 plus 24 plus 2 plus 24 plus 16 plus 4 plus 16. Did my math on the side. I got 100. Then I'm going to also divide that by 8, because there are 8 pieces of data. And I get my final answer is 12.5. Are you ready for an abbreviation? I'm going to call 12.5, let's zoom this out a little bit. I'm going to call this my mean absolute deviation. That is my final answer, 12.5. So this video is 12 minutes, 12 and a half minutes long. I'm going to end it and encourage you that you watch it again. Watch the other video I will post with this. I will make a second mean absolute deviation video and I will post it soon. Okay, in a few days. And Daisy woke up and moved to the door. Bye.